come through. Our speaker today is Mark Crosby, who's President and Chief Executive Officer of the Enterprise Wireless Alliance, and is well known to many of you and is certainly an expert on the topic of emission designators, and I'm really happy that he's agreed to help us through this topic. Mark, would you like to take it on from here?
Thank you, Andrea. I prefer not to take all the credit for this, although I don't think I've ever heard or anyone was bold enough to try to do a webinar on emission designators. It was actually, I learned a lot even putting together this webinar, and I want to start by obviously thanking Andrea. She did a lot of research to help me, which helped me prepare this webinar. And I also want to thank the manufacturers, and there was more than one. It was like 4 or 5 that were very, very, very helpful in providing information regarding emission designators that they have in their equipment, et cetera. So the thank you to Andrea for doing the research was very helpful, and thank you to all the vendors who helped submit information and confirmed emission designators that they had for their equipment, et cetera, which was extremely helpful and gives the some of the information we have in this webinar extremely accurate. So why do we need them? Well, it wasn't that long ago, 20, 25 years ago. Everything's analog, and there's emission designators were not an afterthought, but you plugged it in. I mean, there was like 2 of them that counted. Analog 20K, analog 20K data, and there was like 2 of them, maybe a little bit more. But 99.9% of the applications and the licenses issued in PLMR space, there was 2 emission designators. No one paid a lot of attention. Well, there's a lot more bands that have come into play over the years, and many, many, many more technology advances, digital, analog, TDMA, others, and emission designators are extremely critical today, and we'll get into some details. So, if there were 2 emission designators, say 20, 25 years ago, there are at least 265, it's hard to believe, that are in play today through the various bands by all the vendors, and which are, the emission designator today, and I sort of picked this because it's a good analogy for me. It provides the DNA of the systems that are licensed, and obviously channel bandwidth, digital, analog, and what is it being used for, voice data, or both capabilities. I've learned, and I think many of you already know this already, how do you get emission designators? Well, the vendors pick them. I mean, they have equipment. They send it to OET or the certification houses, committees, and the equipment gets certified, given an FCC ID number, and the ID is, and this is the emission designator for this product. The emission designators are pretty much band specific, although one emission designator, of course, can be applicable in multiple bands. They are not necessarily vendor specific. Many, many vendors have the same emission designator for products that are similar. But again, why do we need them? Well, and I'll get into more detail, but for spectrum management purposes and for frequency coordination purposes and for interference mitigation purposes and for rules and everything, what you need to know, you look at the emission designator and the license.
You are now being connected to the conference. Please stand by.
I hope I'm connected. And so it's the DNA, and very, very important as the spectrum landscape gets a little bit more complicated. So let's look at, for lack of a better term, the anatomy of the emission designators. And I knew enough to be dangerous, about a week ago before I really delved into this. But these characters are very obviously very relevant, and the first 4 characters represent the band. Now, this is something I learned. Necessary bandwidth. The first 4 characters is necessary bandwidth, not occupied bandwidth or authorized bandwidth. Necessary bandwidth. So it's an interesting distinction because the K in this purpose of the one that's illustrated in red is actually in the place is like a decimal point. So the necessary bandwidth of this emission designator is 11.2 kilohertz. And so that's the necessary bandwidth for this product to function, which means it can go in anything like 12.5 kilohertz channel, or which is the 12.5 is the authorized bandwidth. The occupied bandwidth, it may be something because these things oscillate, but the necessary bandwidth for this product and this particular emission designator is 11.2 kilohertz. Interesting. Now, so you go, oh, okay, so 11 tells us that their emission 11K, 11.2 kilohertz, but believe it or not, there are, in the private land mobile radio bands, there are applicable designators in every single from 4 kilohertz, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, all the way up to 22. So you would think, well, there's only like 11 or 7 or 4, or maybe in the old days 20, maybe 21 for some advanced digital technology, but there are emission designators all the way from 4 to 22 kilohertz. But so before we move on, the first 4 define the necessary bandwidth of this product on which it must operate. The character that I've highlighted, the F, indicates the type of modulation. Now, all right, so I knew there were other modulations, but I didn't know there were so many until I looked into this. And predominantly the ones in the private land mobile space is F, frequency modulation, but there are a whole host of other types of modulation. And phase, double sideband, single sideband, full carrier, single sideband, there's vestigial. I pronounced that right. I labored over that for like a week, how to pronounce that. I've never seen any emission designators that we use for private land mobile and coordination purposes with a C, which designates the type of modulation, but who knows? Maybe in the future. Sideband. So these are, believe it or not, there's all of these, and there's actually more. These are other classifications, type of modulation: P, K, L, M, Q, V, N, W, and then just a catch-all. You knew there would be a catch-all. Cases not covered above. David Ironman and some of the people that David's with Motorola and gentlemen at Kenwood and Harris, and they're all very helpful. Power Trunk, and they're very helpful on some of these, but these are just the other types of modulations that are in play in the spectrum universe. I think that 99.9999% of the ones that we deal with are the F back here, frequency modulation. But when you look at these, you look at other licenses. If you see any other characters, since this presentation will be available to you, you can then you'll know what they are. The next to last character in an emission designator denotes the nature of the signal. So we have analog. These are the analog ones. So if you ever look at a license, or when EWA receives an application for coordination, and we see on the app a 3 or an 8, we know that's analog. Every time. These numbers are absolute. It isn't like, oh, it's both. No, 3 or 8. Now, there are some emission designators, obviously forward and backward and compatible. We'll get to that. I mean, some of the systems, but we'll get to that in a minute. But the next to the last number, if it's a 3 or an 8, it's analog. Here are the digital. and again, I don't profess to be a system designer expert at all this. I don't even know what a quantized digital maybe some of the really good technical people and the vendors could help explain it to me, but I don't know if we really need to know that. But I do know if it's a 1, if it's a 2, a 7, or a 9, and we see all of these. Those are digital modulation. There's an X, again, that for purposes of the presentation, just got there. These are cases not otherwise covered, where even the FCC is bamboozled on what the heck the code should be. But so 3 and 8 are analog. 1, 2, 7, and 9 are digital. Every one of these, you'll look at the emission designators, you'll see that these numbers are very prevalent in our space. I see that no one's asked me any questions yet, so I will keep going. The last one, pretty simple. Most people know this. Well, not necessarily, everybody should. D, this tells us the type of information to be transmitted. If it's a D, it's data. Data transmission, telemetry, or telecommand. E is voice, telephony, including sound broadcasting. And I was amazed when I looked at all of the emission designators and what they stood for, which I could have done. I mean, there's a lot of ways I could have formatted this data. We're going to show it to you, and I thought it was the easiest way. Virtually all of it's very interesting. I learned that a lot of the emission designators and a lot of the bands permit sound broadcasting, and it's sort of an interesting term. But E is voice, D is data. If there's a product that does both data and voice, it's a W. And this is important when it comes to coordination and when you trying to advise a coordinator what you want, or for purposes of the license. This is very important that you get this right, because you'll show right in a minute and get into why is this important. It's important to get this right, D, E, or W. Other ones, I don't quite understand this, but there could be an emission designator with an N, which means we're not transmitting no information transmitted. Could be receivers, and but receivers only don't need to be licensed. But there's N's and there's telegraphy for oral reception and automatic reception, and F. There are some products coming into our space, and some of the white like at 800 stuff that have video capabilities, and believe it or not, there's 1 or 2 emission designators with the C code, not commercial, stands for facsimile on a emission designator. But predominantly the ones in our space are D, E, and W. D for data, E for voice, W for both data and voice. All right. I didn't quite know how to present this data, so I said, you know what, I'm just going to show them all. I could say, oh, here's the predominant ones, but I'm going to show you, I'm not going to read them all off. But, and again, remember what I said, the emission designators are not particularly aligned with only one vendor. Many emission designators, many vendors are using the products virtually identical, just, different skin, et cetera, maybe some different applications, and et cetera, but the emission designators are the same. But 4K, these are the 4K emission designators. And this product can be deployed at 150, 220, 450 to T-band, 700, 800, and 900. And this is pretty common with some exceptions. You'll notice that the technologies at 4K include analog, because you can see the 3, a couple of them have the 3 next to last. That's analog. And data, all the other ones are data. The X, the 1, the 2, the 1, the 9, the 7. I'm talking the 2, I'm looking at them. They're all data. And these products, various sundry, depending on the emission, it can do data, telemetry, sound broadcasting, and telecommand capabilities. But these emission designators, there are products in VHF, 220, 450 T-band, 700, 800, and 900. 5 and 6K. Note that there is a voice 5K, the 5K 60 F3E. This is a voice analog 6K, and the research that was done. By the way, all of these are coded in EWA spectrum management frequency coordination, because if you try to put a wrong emission designator on an app, we certify it, goes to the commission. They say that's not a legitimate emission designator. We got to get it right. So we sort of have backup. This is hardwired into our computers, but obviously we need to maintain it because the vendors are coming up with new products and new applications and new capabilities, et cetera, and some of the products require new emission designators. But these are the 5 and the 6K. They're available, and none of this is in 220, because remember 220 is 5 kilohertz channels, and so, for example, the very first one would be 5.0 kilohertz, and that's right at the edge of the authorized bandwidth, so it's probably not good because you don't have any wiggle room, can't oscillate. And obviously the next one, the 5K6, is 5.6 necessary bandwidth, so it obviously needs to be in bands and in channels that can accommodate that bandwidth, or that necessary bandwidth, which would be 6.5, 7.5, 12.25, stuff like that. So, and that's why products with these emission designators are available at VHF, 450 T-band, 700, 800, and 900. 7. Notice that there are no analog 7K emission designators. All products with the 7K, which is 2 voice pass, it's all digital, and obviously has you can see the W, which is both voice and data, some data only. There's a C code, so one of these products does facsimile. That first one, 7K00FXC, is distinction. It's not data; it's doing facsimile. Don't know if we've ever coordinated one of those, but maybe we have. But again, digital voice, data, telemetry, sound broadcasting, and telecommand capabilities, 7K. If you think you're done, we're not. Here are the 8Ks. A lot of P25. A lot of vendors have using, multiple vendors are using some of these emission designators. Obviously, some of the emission designators are unique to certain vendors because they have different applications or different other things that are attached to the voice, and it needs a little bit wider necessary bandwidth. So you can see the first one's 8.0K, 8 kilohertz, but some of them, because of some of the other features and capabilities, are a little wider. And for example, the last one's 8.7K. So in that extra 7 kilohertz, you can do data and telecommand and other type of telemetry and other type of applications. Note also in this space there are also a few analog products, because the 3 is recorded in the emission designator. But again, products are available in VHF. These emission designators are applicable in virtually all the land mobile bands. 9, analog. That I don't think we mistyped that first one, but 9.8 kilohertz. It may be. Listen, there's 265 of these things. We'll double check. And again, I know, anticipating that many people on the call would go, can we get a copy of this? Because we may want all these emission designators. Again, we're going to put it on our website, or somehow we'll get it to. We're happy to share this with you. But again, products, VHF, UHF, T-band, 7, 800, and 9. I was also amazed when I looked at all this and put it together and compiled it based on the research that Andrea did, verifying with the manufacturers, how many products there are at 900, 800, but 900. because of the 12 and a half kilohertz channels. So when you get up in the higher bandwidth, which we'll see momentarily, those products obviously can't be deployed at 900 because the necessary bandwidth exceeds the authorized channel bandwidth. Here are the 10Ks. Again, multiple vendors, all the major bands, and virtually all of the capabilities. 11K, there's a lot of them. There's another fact. You'll see the C code there. There's another facsimile application, but obviously a pretty popular 11K, ranging from 11.0 to 11.8. Obviously, plenty of room in a 12.5 kilohertz authorized channel. At 450 T-band, 800, 900. There are the 12 and 13s. Now these are a little bit too wide to fit in VHF. They obviously some of them fit at 450, some of them do not. So the necessary bandwidth's too wide. Obviously the 12.0s work, 12.1s work, 12.5 and up probably doesn't work. The 13Ks obviously don't because they're too wide. I don't know why. I looked at the data. Some of this stuff is at 900, but 900 is 12 and a half bandwidth, but there's some of them they were still certified for 900. How that works, I'm not quite sure because they seem to be, too broad or the necessary bandwidth exceeded the authorized bandwidth. But the data that our research showed that there are products, maybe if there was too contiguous, I'm not quite sure. But these are the 12 and the 13 kilohertz bandwidths. Here are the 14s and 15s. These are only certified for 700 and 800, which tells me they're public safety. And analog, there's some analog, voice, and again, data, telemetry, sound broadcasting, and telecommand capabilities and applications. But these emission designators were only applicable in the 700 and 800 band. 16 and 17, again, only 700 and 800. That's what we saw, that they were submitted and authorized. Products were authorized with these emission designators in those bands. I believe there were multiple manufacturers. 18 and 19, again, only 700 and 800. A lot of data. Virtually all of it was data, except that one 18K3D7W, which is both voice and data. But the majority of these products were all data with a D. And if you have a D, it's not doing voice. The commission wouldn't authorize wouldn't give the FCC ID. If it's doing both voice and data, it'll have a W. If it's only doing data, it's got a D. So, this is like, I love it when you do this. It's always the case, and not maybe. If it's got a D, it's data only. W, it's voice and data. So the 19 kilohertz are, as you can tell, they're all data. 20Ks, a lot, both analog and digital, 700 and 800 only. These are necessary bandwidths are wide, 20K or greater. I guess the widest one was 20.2. That 9's a code that it's doing more than, the F9W. That 9 tells you that it's got a lot going on in the transmission. Got more things, and that's probably why it needs another 2 kilohertz. And these emission designators are only at 800. TDMA, 4 voice pass. Some of them, now, we'll get to how you use some of these because they're sort of important, but these are, I believe, 99.9%. If you asked me to swear to it right now, I wouldn't. These are Tetra. However, some of them are Tetra. Some of them are also telling you that you have DMR technologies taking up 21 kilohertz of authorized bandwidth, but you can put, we'll get to this in a minute, you can put multiple NXDNs or multiple turbo in at 800 using, I think the top emission does those 21s, and we'll get to the rules of the road and how you do that. But these emission designators are 800, and you'll note that there is no analog. These are all digital, probably all multiple path, a lot of throughput, minimum. Well, I think most of these are 4. So these are very effective, very spectrum efficient emission designators. I mean, they tell you that the system is extremely efficient, using a heck of a lot of the authorized bandwidth. 22K, I mean, there's 3 kilohertz left, so on the sides. So these are very efficient and applicable only at 800 megahertz. So one of the questions that came in might be a good time to answer it is, so does the emission designator specify technology? Well, yeah, I think, if I understand your question, it tells you whether it's analog, tells you whether it's digital, tells you the necessary bandwidth, and tells you what it's doing. Data, voice, combination, telecommand, facsimile, video, and ever. So I guess if you're, the emission designator does tell you the technology, what it's being used for, necessary bandwidth, applications. It doesn't obviously doesn't tell you the vendor, and it doesn't necessarily tell you the band, although as a coordinator, the products are designed for certain bands, and the emission designators are unique to certain bands. So I think to answer the question, so does the emission designator specify technology? The answer is yes, it does. All right, I'm sort of going through this quick, but I mean, you didn't expect I don't know if you could do a two-hour-long webinar on emission designators. However, they are so important today. So I have some recommendations for those of you that are responsible for licenses, or your company has licenses, or you help secure licenses for your customers, or you're a vendor. Don't guess, on the emission designator in the app, because since emission designators do tend to specify, give the DNA of the system, and since frequency coordination is much more complicated than it used to be because of all the various technologies and digital and analog and bandwidths, et cetera, emission designators, they help us pick the optimum frequencies or select the optimum frequencies. So don't guess, and you don't really need to. I know. Well, give EWA. Yeah, it's 11K. Give them the old 11K FO30E. Yeah, give them that. Oh, maybe don't do that, right? But we're happy to take what you give us, and we can coordinate it. We're obviously coordinated in compliance with the rules. But don't guess, because it's sort of like, I'll use another analogy. Look at blood type of the system. I mean, you got to let us know. And the stuff is sort of sitting, the data to get it is probably on the product brochures. And, you bought this product, and you get the brochure, the specifications. You'll find emission designator on those specifications. If you're dealing, because I'm not picking on anybody, but salesmen know how the vendor, they're very good at selling, they know the features and everything. And if you ask them, well, what's the emission designator, their eyes would cross. And you go, well, can I see the product specifications so I can see the emission designator, because that sort of tells you what they're selling you. And so it's good. And, if you don't get it from them, well, go to the FCC website, and we put it in the presentation. You click on that, and you can go in and look at it if you have the time or the inclination to look at all the emission designators. That's sort of what we did. And when I started this webinar, I had no idea that there was 265 designators that I went through today, and they're all alive and well. I mean, they're all in play. And there's a couple that you can't use anymore in certain bands, like obviously the 20K. Anything over, 12K at VHF and UHF, or 12.5K, you're in violation of the narrowbanding requirement, except some of the more sophisticated technologies that have the equivalency of operating at narrowband, 12.5 kilohertz efficiency and throughput. But if you don't get it on the product specs, or the salesman doesn't know, or the vendor goes, for example, they go, well, does it make a difference? You now are armed, for those of you on this webinar, if somebody goes, does it really make a difference with the emission? Your answer is, well, yes, it does, because I now might get better frequencies. I now know what I'm buying from you. It makes a big difference. And so don't guess. Here's the emission designator. And here's another tip. we can tell when people guess when they go, yeah, here we have this app, and these are illustrative examples. We want 4K and 7K. Now, 4K and 11K is okay because that product may be backward compatible to an analog and be forward compatible to a digital 4K. And the same thing with a 7K. You can put 7K and 11K in the same license because that tells us it's in migration. You have products from both that are compatible, and the product may be compatible. But 4K and 7K is not compatible. Those are two different technologies, two different vendors, and they don't talk to one another. And it's not possible for them to talk to one another. You'll hear a noise. So when we see that, we go, this applicant might need a little help to understand. We'll call and go, which one do you want? Because it makes a difference, a big difference. And we know that if you put a 4K and a 7K on the same license, you're only using one. I doubt you're using two different products in the same system from two different vendors. Pick one. And because if you put two in there, you take spectrum off the table that we could possibly look, and it's sort of like it doesn't make any sense. So, and don't guess. Again, don't guess. Because, we don't like this. And, people do it, but we know that means that the information in the ULS and in the coordinator databases having a 4K and 7K just is illogical. Another one, just for illustrative purposes, a 20K OD7, which is a digital voice and data. That could be Turbo or an NXDN or another advanced DMR technology, but it's not going to be compatible with a 22K Tetra. So, if you put those on the same 800 megahertz license, we know, well, which one are you using? And because both of them on the same license doesn't make any sense. Another recommendation. Don't put designators on the license that, we may need this one, or we're thinking about it, and so we know we got 4K, but we may want to do something down the road. No, don't do that, because we'll tell you why. Again, it provides the DNA of the system that's going to be licensed, and the next screen will sort of show you how we use them, and it's sort of like minutia on a license. If you're going to, we may use this a couple, don't put it on there, because it's information that doesn't help the license, and it sort of hinders picking good frequencies for you. It isn't hard to add a emission designator to a license. It's an administrative update. It's like $100 plus an FCC change. So we have apps come in and the guy go, what emission designator? And they go, we want 4, 7, 11, and maybe when all the moon and the sun aligns down the road, we can do four voice pass TDMA on this thing and give us a 22. We go, no. Which one's in play today? Because we want to maintain the accuracy of the database, and it helps us from a spectrum management standpoint. So, we at the end of the day, EWA has to put, when we submit applications to the Commission, legitimate emission designators that comply with the rules. We'd prefer that you not put it in, this doesn't help you, to put emission designators that you're not going to be using immediately. So just sort of recommendations. I ask my staff, so the people that are in the trenches, how often do you get asked this? And they go, every day. I go, what do you mean every day? They go, people come in and go, I don't know what emission designator, give me these 3. And we go, oh my God, you got to go back to them and say, no, which one are you going to use? What product are you buying? What are you planning to buy? And because it's just so important now. So why is it important? The basis of selecting frequencies today, whether it's a shared environment or an exclusive environment, at least for EWA purposes, in the bands below 470, everything's contour based. For somebody asked us for 2 channels in LA, the system will do, since there's say at 450, I don't know how many channels, 400 channels, and there may be 50 incumbents per channel. So that's 50 times 400 is 2,000 to and from. The computer will do 4,000 contours in a matter of a minute or so, the interfering in the service contour. The emission designator we can, because you have to, the geography stays the same. The coverage stays the same whether you're using 4. I mean, it'll be a little bit different. But for the majority of private line mobile products, whether it's 4K, 7K, 11K, whatever, it'll propagate pretty much the same. Digital, obviously different than analog. That's a different webinar. We know that analog fades and digital goes great and then drops off into oblivion. That said, if we're coordinating, I don't know, a 4K, you can get closer from a spectrum standpoint with proper. You can find more exclusive channels, et cetera, because the system will look at the emission designators, and you know, 2 12s have to keep. There's overlap. You can't put a 6 in between them, 6K. But if there's a 4 on one side and a 7, there's capacity, and the contours will take that into consideration. You might be able to do a 4 or 7K with the adjacent or co-channels of different technology. So that's why it's important to have the right emission designator. Because if you give us, I don't know what the other coordinators know, but I know what we do. If you give us 4, 7, and 11, the computer will run at 11 because we might be able to find better channels at 7 and 4, but you gave us 11. So we have to do it at 11 because that's the most conservative. I don't know which one you're using, but for purposes of picking frequencies, we must pick the widest, which would be the 11K, which potentially takes potential frequencies off the table that we can certify that might be better for you. Certain channels at 450 are limited to very narrow bandwidths. Okay, you know this. So when you give us, if somebody gives us an app and goes, we're looking at, say, 4 and 11. Well, we're going to look at the 11, and 11 emission designators don't fit in 6.5 kilohertz only channels that fall between 12.5 kilohertz channels. So when you get, those are 4Ks. So if you want to expand the universe of frequencies we can look at, make sure you give us the right emission designator, the one that's going to be fit, because it helps us identify the universe of frequencies that can be selected. And just to show how the future, since there's greater sharing and technologies are being mixed, emission designators tell us the technology, tell us, again, the DNA, what's going to be used. And for a perfect example, at 800 megahertz, there are 319 mid-band channels that are eventually going to become available when it gets out of the Bureau at the Commission. But there's 319 800 megahertz interstitial channels that are going to be 12.5 kilohertz. They fall between the 25 kilohertz. As a coordinator, I have to take into consideration the incumbents on the 25, as well as the proposed people that want to go in the 12.5s. And to maximize efficiency, to make sure this works without causing interference to incumbents, and as well as to provide optimum spectrum solutions for the person that wants to use the interstitials, the entire process will be based on emission designators. So co-channel, pretty much the same, 88 kilometers. We know what's going to happen co-channel. Adjacent channel, depending on what's proposed as the emission designator and what the incumbent people are using, the interfering contours that will be used will vary depending on the emission designator. Because you can put a 4 next to a 4, you can't put a 20 next to a 4. So the emission designator is absolutely the basis of coordinating 319 interstitial channels at 800. I think it's the future, because as more technologies and more sharing takes place, the emission designators tell us what this system is doing, how much bandwidth it has, whether it's data, whether it's voice, etc., and it's crucial as for spectrum management and frequency selection purposes. A couple other spectrum management considerations. I get mixed feedback on this from some of our vendors. Some people go, oh, I was told if I have both data and voice to list both a D emission designator and an E emission designator, which tells you voice. I'm not a fan of that, and I'll tell you why. because unless the emission designator that's specifying data is on a data primary channel, it's secondary for voice operations. So when you have a D emission designator, that tells the world that if it's causing interference to a voice system, the D emission designator is operating on a secondary non-interference basis. You either shut down the D or resolve it some other way. Don't do it. If the product is both data and voice, don't put two emission designators on a license, a D and an E. Do the W. And then everything on that one is primary, the co-channel and compass. It's sort of a simple little thing, but why put two emission designators on it if the product, and you verify it, that it qualifies for it's both voice and data? Do the W, don't put a D and an E, because the D is secondary. And you know what happens when there's interference? You're not going to win that battle. Well, you know, it's primarily using a voice. And go, no, 100% of the time. Data system causes interference to voice, which is primary on the channel, the data loses. And so just think about this when you submit applications or even look at the various options for products. I mean, it's fine, but just if you can do the W, do the W, because I think that helps your standing on the frequencies. And one of the other things that we have that is happening more, because I think one of the more crucial bands in the future is 800, is because the technologies that are being developed. And listen, I always do this at risk of I don't mean to get anybody's upset or anything, but 800 is sort of like really important, and the channels are all 25 kilohertz. So if you have 25 kilohertz, you can do tetra, 4 voice pass. You can do 4 next edge, 4Ks, 4 voice pass. Or you could do 2 7Ks, they give you 4 voice pass. So, and to make that happen, we've worked on these. There's nothing, because it was like, we get this question all the time. Can I do, one came in today, I owe somebody a call. I got a customer who's got 800 channels. I want to sell them multiple, technology that does multiple voice pass. Can I do that? The answer is yes. And the way to do that is there's an emission. We have to verify, depending on the product and stuff, but I'll do both examples so I hopefully don't upset anybody. If you're doing turbo, there's a 21K emission designator. And what that does on that license is tells the world, I got this channel. I got 21 kilohertz of this 20. This is my channel. This is mine. However, you also add to that license the 7K, which tells us, the FCC and anybody else, that this channel is occupied by multiple 7K channels that are using those channels, and this 21K locks it in, and the 7K tells people what technology is in play. The Tetra is one emission designator with the 22s and maybe the 21s and the 21, and that tells I have one technology but 4 voice pass. And for NXDN or NextEd, same thing. There's a blanket emission designator for multiple NXDNs, and so you put the 4K and the 20K or whatever that one is, and you can, at 800, you secure the 25, and you can do multiple technologies to get the 4 voice pass, which is extremely spectrum efficient and supported by pretty much everybody to use that band to, it's just great. And but there's a way to do it, and it's all done through the emission designators, which if there's any theme you take away from this is, emission designators are very important, and we better get them right, because if we don't get it right, we could, the license may be incorrect in frequencies, whether you get the proper license, and down the road, people looking at that know what you're operating, and that's very, very, very important. So let's see, there aren't any more questions. I could have gotten into more detail and the history of emission designators, but this is today, and if you want copies of this, you have the list. of 265 emission designators from 4 to 22. Paste them to your wall. Go to the website. You have them. Here are the recommendations. You know, there's only a couple tips. Get it right. Verify. Pick the right ones. Don't guess. And because it can only help you. So at this point, actually, we did that at 45 minutes, which is more than I thought it would be. Are there any questions?
Ours is like 4 times.
$5 a month for 10 to 5. I said, Chris, do you realize I get 49?
Somebody's asking things in there. Okay. Any more questions? I could pick on people, and I know we're on the call, but that's okay. I hope this was helpful. If nothing more, you can get a list of all the emission designators, all 265 of them. Know that it's not an absolute list. The list is going to be iterative. Vendors will be putting in new products and new things, so that EWA must stay on top of this too. And it's very helpful for vendors to let us know this is something new we have, and here's our new emission designator. And so that's all we have. Next webinar is slated for November 10th, 2 p.m. Eastern. There's been a lot of publicity. I noticed that Mr. Sanders asked me a question I'll get to in a moment. There's been a lot of conversation and about the national carrier's effort to do POC in our space. And, there's risks and there's rewards with that choice. And to make sure that there's a fair view of that potential application, we're going to do a webinar and go, hey, this is the good news about it, and here's potentially the bad news about that solution. And so that's the next one, November 10th. So we have a question. Let me read it. If the W isn't on the grant equipment authorization, can we still be used when FXD and FX is shown? Well, FXD and FXE, so that's at the end. It's equipment specific, Alan. If it can't do voice and data, if the product cannot do both at the same, in the same unit, I don't think you should put the W. If you have multiple units, one's D and one's E, well then you got to list them separately. But I think to answer your question, can it still be used? Yeah, if the equipment has that emission designator, right? I mean, I wouldn't make it up. In other words, for heaven's sake, the unintended consequence of what I said is, oh, I got a D, but I'm going to make it a W, because then it won't be secondary. Now, that would mean your license is in non-compliance with the rules. So look at what the product emission designator is at for product. If it has a legitimate emission designator for W, use the W. If it doesn't, don't put the W on there. Hopefully that answered your question, Alan.